So, Jai Hind, all of you once again. So, I am Manish Kumar, Assistant Professor in CSC Department at Ajay Kumar Engineering College. So, today one of the complex topic is genetic algorithms. So, today I am going to brief you about a genetic algorithms. That is a complex topic in unit number 5. So we have early studied that what is machine learning. We have discussed several times that machine learning is a multidisciplinary subject. So in machine learning, we have lot of long problems that take lot of time. We used to implement number of algorithms in machine learning. We used to solve several classification problems here, several optimization problems here. So genetic algorithm is basically used to solve these optimization problems, and very large complex problems can be solved very easily with the help of the concept of genetic algorithms. So as the name comes in our mind, this genetic algorithms came from the biological background, because genetics that is inspired from the biology. The topics that comes in our mind is what are chromosomes, what are genes, and so these are the biological terms that came in this genetic algorithms, this in machine learning. So as I have earlier said that it is a multidisciplinary subject. So genetic algorithm will help in machine learning to solve these optimizing problems, very large optimization problems. So we will get a solution very easily here. So today in this lecture, I am going to brief you about the introduction of genetic algorithms, how it is connected to our computer science, how it is helpful in machine learning to solve those problems, how we can easily implement it. Okay, so let me start. So genetic algorithms. So I will give you the overview of the genetic algorithm, what it is, how we are inspired from, what is the theory behind this, what are the different operators, different parameters, and at last I will summarize all those concepts for the implementation in machine learning. Okay, so let me discuss about the history of genetic algorithms. So as we know that this evolutionary computing was first introduced in 1960 by I. Reichenberg in 1960, and again in 1975 John Holland wrote a first book on genetic algorithms, and the name of that book is Adaptation in Natural and Artificial Systems, that he wrote in 1975. So these are some history facts that I am just going to brief you. In 1992, again, John Koza, very famous name, John Koza used genetic algorithms to evolve programs to perform the certain task. Because we know that in programming, we will use several techniques, several logical techniques. So different programs can be solved using different techniques, different logical techniques. So certain tasks are used to solve using these genetic algorithms. And he called this method genetic programming. Here comes the name of genetic programming. So John Koza used this word first time in 1992. So what programming is? We know that programming, we will use certain logic to solve a task. Okay, so that is genetic programming. Okay, so what are genetic algorithms? So as I have brief you about genetic algorithms are used to solve optimization problems. Okay, we can also describe it as a heuristic search, as a heuristic search. You can define it as a heuristic search algorithm. Okay, so genetic algorithm as a heuristic search algorithm, algos which are used to solve optimization problems. Used to solve optimization problems. So this is a definition that we will use. Okay, genetic algorithm defined as a heuristic search algorithm which is used to solve optimization problems. Okay, and I have already told that they are used to solve optimization problems in machine learning. So what is the use of genetic algorithm in machine learning? In machine learning, this genetic algorithm is used to solve optimization problems. Okay, that I have discussed already. Optimization problems. So those big problems can be solved very easily. That the solution we get in machine learning with the help of the genetic algorithm. Okay. So genetic algorithms are search and optimization. So these are the two keywords: search and optimization technique. Okay. And these techniques are based on Darwin's principle. This is one of the famous principles that we use, and that principle of natural selection. Everybody heard about this Darwin principle. That the principle that says that everyone is trying to survive for his fittest, for its fittest, that we have studied in biology. We have already studied, there is a life cycle going on in biology, we have studied. So according to Darwin principle, everyone is trying to survive for its fittest. So that is the that optimization technique, that search technique, that algorithm is based on this Darwin principle of natural selection. Okay. So what is Darwin principle of natural selection? Let me show you here. If there are organisms that reproduce, now, these are the principles that given by Darwin, principle of natural selection. Okay, I use the word if. If. Where we can use natural selection? Number 2, if offsprings inherit traits from their progenitors. Okay. Thirdly, if there is variability of traits. Fourth, if the environment cannot support all members of a growing population. Then what this theory says? Then those members of the population with less adaptive traits will die out. Obviously, if the population which is not able to survive according to the environment, then that population will be die out. So what happened with this span of time? As the time goes on, that population will try to survive. Then those members with more adaptive traits, which are more adaptive traits that which can survive according to the environment, they will survive, will thrive. The result is the evolution of species. So this is the theory, because here it is clear that when there are organisms that are reproducing, and if those organisms will not survive with the environment, they will die out. If some of them having more adaptive traits, they are more capable of surviving according to the environment, they will survive, and that results in evolution of species. New species will be generated, and that species will be survive according to the environment. Okay. Otherwise, the species which are not able to survive, which do not according to that environment, they will die out. So this is the principle of Darwin principle that given by Darwin on the basis of natural selection. Okay, that we used to say that everyone is trying to survive for its fittest. So whosoever survived will thrive. Okay, and that will result in the evolution of species. Okay, so these are the biological terms. So this comes from the biology. So genetic algorithm, this term comes from the biology, and the inspiration is that Darwin principle. Okay, so the basic idea of principle of natural selection is select the best, discard the rest. So select the best. So whichever species having the best capability of surviving in the environment, that species will survive, otherwise other will die out. So this is the basic principle of genetic algorithm on this Darwin's principle. Select the best, discard the rest. So you keep in mind this. Okay. So I will just try to brief you an example of this natural selection. So we have seen in our surrounding there is an animal called a giraffe, and a giraffe's having a long neck. Okay. So those giraffes having a long neck, what is the reason of those giraffes having a long neck? Because we know that they are having long neck. Because why? Because they can they feed on leaves of trees having higher branches, and the length of that trees, the taller trees, they can survive. Because okay, so they had a better chance of survival. That we can say that they have a better chance of survival because they can feed on leaves of higher branches, because they have better chances of survival. Okay. And the favorable characteristic propagated through generation of giraffes. Okay, now evolved species has long necks. So nowadays, so it's from a long way back, we have seen that it may be a case that giraffes are having a short neck. But as the time spends and they are trying to survive. So due to that survival, they are trying to survive to those giraffes having long necks. So this is an example of natural selection. So naturally, these giraffes will mutate into the giraffes having long necks. Okay. So because longer neck giraffes have better chance of survival. So longer necks may have been a deviant characteristic initially, but since it was favorable, was propagated over generations. Now an established, so it is an established trait. It became an established trait now. So we can say that this mutation is beneficial for the giraffes because they are better chances of survival. Okay, so this is an important example of natural selection. Okay, so we can give this example of giraffe which are having long necks. Okay, so let us discuss this evolution theory that is based on this natural selection. So there are several, we know that there are several ways of solving a problems. We can represent a problem using several ways by the help of algorithm, by the help of flowchart. So first of all, we have to discuss that how we are able to represent how this species are evolved, that best trait species are evolved. Okay, so initially what happened, we have an initial population of animals. Okay, so each animal is trying to survive for its fittest according to this Darwin principle. So there is a struggle for existence, for existence, survival of the fittest, which we said is survival of the fittest. Okay, that population is trying to survive. Now next, surviving individual will reproduce, whichever survive, then that animal will reproduce, that will propagate favorable characteristic. So according to the environment, favorable conditions according to the environment, that species will propagate. Okay, and that will result in an evolved species that is survived according to the favorable characteristic. That we said a new trait of species will be generated. Okay, and this will happen, this will take a long time, million of years will take. Initially they will die out, but after the millions of years, keep on trying this, according to this theory, survival of fittest, they will propagate some favorable characteristic and new species will be evolved. So this is the evolution through natural selection. Okay, so this is a loop that will go on, that will go on, that will go on, million of years. So it will take million of years to evolve a species according to the favorable characteristics. Okay, so how it is genetic algorithm implement optimization strategies by simulating evolution of species through natural selection. So genetic algorithms will implement that. I have said that it is used to implement optimization problem, easily implement optimization problem in machine learning. So by simulating evolution of a species through natural selection. So we will use this natural selection theory. This natural selection theory will be used in genetic algorithm. Okay. So this is the working mechanism of genetic algorithm. This is important. This working mechanism. So in beginning, this is a flow chart. This working mechanism can be represented using a flow chart, or we can also represent an algorithm also. There are several ways of representing a technique. We can also represent an algorithm. So before discussing an algorithm is a step-by-step representation, flow chart is a graphical representation. This is the only difference. Okay? So this is the flow chart. Let us start. This is the beginning, starting species will evolve, initial population. Okay? Then we have an evaluate solution is there. Solution will be evaluated. Either we will check it is optimum or not. Optimum solution we will check for optimum. This is a decision box. If the solution is best, optimum solution, then yes, and the algorithm will be stopped. Otherwise the solution is not optimal, then what will happen? This is n times. This loop will go n times. So these are the three main key points that we have to keep in mind in this evolution of the new species. Number one is selection. Number two is crossover. Number three is mutation. So these are the three key steps that were involved in genetic algorithm. Selection. Selection means we are going to select a particular species, particular population. We will select. we will check whether after selection that solution is optimum or not. If it is not optimal, then we will generate the new solution. How it is generated? It is generated using the second process called as crossover. Crossover is a process usually used, you can understand it with the help of this biological term that we use, chromosomes. One chromosome will cross over with another chromosome, and that will generate a new species, a new gene will be generated. है crossover. Mutation again, it will help to mutate a generation of new species. It will go on until unless we will not get the optimum solution. This is the going on process that I have discussed before, that it will take lot of years. So this lot of years, how it is generated? By using these three concepts: selection, crossover, and mutation. So we will discuss this in brief. What are the different techniques? What are different techniques that we use to mutate the new species, to generate the new species, to generate. So means the question is that is we are getting this solution optimal or not? Okay. So whenever a question is asked about the working of genetic algorithm, so you have to elaborate this flow chart and explain each step briefly. Okay. Yes. Now this flow chart can be represented using this algorithm. This is a simple algorithm. Okay. So simple genetic algorithm. This is the name of our algorithm, the function that we call it a function. Then initialize the population for what we are generating a genetic algorithm. Yes. Then we calculate the fitness function. There are some terms that we have to keep in mind while studying this genetic algorithm. Some of the terms that I have already saying before, that is what are chromosomes, what are genes, what is genetic material. Another term is population, that is mostly used in this genetic algorithm. What is fitness function, what is selection, what is crossover, what is mutation. These are the terms that we most of the times used here. Okay. So on the basis of the fitness function is you just consider it as a criteria which is used to consider whether that algorithm, that solution is behaving according to our requirement or not. If the population that is calculated on the basis of that fitness function, if that fitness function, the output of that fitness function is optimal, then we will proceed. Otherwise, we will not proceed. Okay. So we will calculate the fitness function. If that fitness function is equal to our optimal value, then it is okay. Otherwise, if it is not equal to optimal value, then what we will do? We will, number one, we will use selection on the basis of natural selection, survival of fittest. Okay. Whosoever is able to survive will be selected. Number one. Then secondly, new species will be reproduced. Reproduction will be done with the help of this crossover. Reproduction, propagate favorable characteristic. Which population is survive according to the environment? Okay. According to the favorable conditions of the environment, that will able to reproduce the new offsprings. Okay. So that is done with the help of crossover. Okay. Then mutation, we will use mutation. Mutation is also an important technique, we can say important feature of genetic algorithm that will help to give rise to new generation. Okay, na? Then again, after selection, crossover, mutation, then again we will calculate the fitness function. If again that fitness function is not equal to optimal value, then again this process will repeat on. Okay, see, I have already briefed you that it will take million of years. Okay, so this is the biological, according to the biological concept. If according to the genetic algorithms, I am using the selection, crossover, and mutation, and this is how the base fitness function is used. How the fitness function is calculated. Okay, so while the fitness function, this fitness value is not equal to the optimal value, these three processes will go on until or unless that fitness function is not equal to our optimal value, which we are going to implement. Okay, which we are going to solve. ठीक है. So we can say that this genetic algorithm is used to solve several complex problems, several complex, bigger, longer problems. ठीक है. And genetic algorithms is widely used for different real world applications also. Different real world applications. Real world applications, for example, if I say you for the designing of electronic circuit also, the concept of genetic algorithm is used. Number one, designing an electronic circuit, है ना. Also for code tracking, we can use the concept of genetic algorithm. ठीक है. It is also used in wide applications of image processing and artificial creativity also. This genetic concept of genetic algorithm is used. Okay, so it can be used in very real world applications. Real world applications can be implemented in real world applications. For example, what are those real world applications? What are for designing the electronic circuit? Electronic circuit. Okay, number one. Or what we can say that for code breaking, we can use the concept of genetic algorithms. Okay. Third real world application that can be used is, I have said that in the several applications in image processing, or we can say that on artificial image processing and artificial creativity. Artificial creativity solution for providing artificial creativity solution. These are the several applications, real world applications, है ना. And we have used several times these terms also. You should also keep in mind. Number one, population. What is the population? Population can be defined as a subset of all possible, we can say all possible or probably the solution which can solve the given problem. This population, this word population is widely used in genetic algorithm. It is defined as a subset. This population can be defined as a subset of all possible or solutions which can solve the given problem. Okay. Another term we can use here, this is number one is population. Secondly, we can use chromosomes. Okay, I will just brief you what are these terms that are what the meaning of these terms in our computer science. What population representing the number of n number of problems that is coming. What chromosome is defined as the one of the what we can say that the solution in chromosome can be defined as solution in population. Can be defined as a solution in population. Okay, for given problem. Okay, and it can be defined as a defined as a collection of genes. Chromosome can also be defined as a collection of genes. Okay. Now the question arises: what is genes? Genes is an element of chromosome. Gene, this is another term. Genes is an element of chromosome. Okay. What is fitness function? This I have already briefed you. Fitness function, it is used to determine the individual's fitness. Fitness function is used to determine individual's fitness. ठीक है ना? That level, individual fitness level. ठीक है ना? Where it will be found? Individual fitness. Obviously बात है. We are discussing in population. Individual fitness level in population. Okay. ठीक है? Why we used to compute this? Why we used to compute this fitness function? Why we used to determine this individual fitness level in population? So that we can so that we can compete with other individual. So that particular we compete with another individual. If we get this value is equal to optimal value, we are going to this compete with another individual. So to compete with another individual, we are just going to calculate this fitness function. Okay. So this is the basic. These are the basic terms that are used in genetic algorithm. Okay. So I think this is very clear. I have very briefly I have explained all these concepts. Okay. So should we move? Yes. I am talking about this nature to computer mapping. So in nature, we are discussing about, we always use the term population. But in our computer, what that population means? That means set of solutions. Okay. Number 2, individual. In nature, we will use a term individual. Individual means solution to a problem. Okay. Thirdly, fitness. Fitness means quality of a solution. Okay. Chromosomes means encoding for a solution. Okay. In nature, what is a chromosome? Chromosome is a set of, I have briefed you this chromosome, just give the solution. Na? And in this computer, what does this chromosome mean? This means that encoding for a solution. Gene, it is a material, okay. But in computer, it is a part of the encoding of a solution. Okay. What does this reproduction means? In biology, in nature, we will use a term reproduction, but in computer, we will use a term crossover. Okay. So I think this is clear now. Selection, natural selection, survival of fittest. So whosoever is survived, it is selected. Number 1, which is selected, then it will reproduce new, propagate according to the favorable characteristic, that is called crossover, and mutation will be done. Then we will calculate the fitness function. Okay, na? Why fitness function is used? To determine the individual fitness level in population. Okay. What is population? Population, it will give, population is just the subset of all possible solutions. Population is the subset of all possible solutions. All possible solutions. Okay. Okay. What is a chromosome? Chromosome is a solution in population for given problem. That is a collection of genes. Okay. So this table is important to understand. Okay. So these are the terms, these are the terminologies that we use in biology, and what these terms means in computer, I have brief in this table. So this is nature to computer mapping that I have said it. Okay. So keep in mind, population is a set of solution, individual is a solution to a problem. Okay. Fitness is the quality of a solution. So what we are doing in genetic algorithm, we are checking this fitness function. We are checking this fitness function. Okay. Either we are getting the solution optimal or not. Okay. Then chromosome means encoding for a solution. Gene is the part of the encoding of solution. Reproduction is the crossover. Okay. So these are the basic terminologies that you have to keep in mind while studying genetic algorithm. Okay. So next, I am going to discuss about some genetic algorithm operators that we use, some parameters that we use. So the first is encoding. What is encoding? We have studied in computer science, the encoding means to code something in some special language which computer understand. So the process of representing the solution in the form of a string that will convey some information, some necessary information, that is called as encoding. Okay. So for example, just as in chromosome, each gene controls a particular characteristic. That we know that in biology we have used a word chromosome. That chromosome will represent a particular characteristic of the individual. So similarly, each bit in the string, in computer science, we represent that string in the form of bits, that is 0 or combination of 0 and 1s. So that if we represent the characteristic of the solution, that is encoding. Okay. So what are the different methods? Number 1 is we will use binary encoding here. Okay, na? So this is the most commonly used method. So here the chromosomes are strings of 1s and 0s, and each position in the chromosome represents a particular characteristic of the problem. Okay. So for example, this is the chromosome A, this is the chromosome B. So in computer science, in computer system, it will represent as a sequence of a string that will consist of bits. Okay. Second is permutation encoding. Okay, permutation encoding means, for example, we are using a particular sequence. Just, as we have studied in mathematics, permutation and combination. So like that, we use the sequence. So it is useful, for example, why it is useful? It is useful in ordering problems such as traveling salesman problem. So in traveling salesman problem, every chromosome is a string of number, and each of which represents a city to be visited, which city we are going to visit. So chromosome A represents another sequence, and chromosome B represents the another sequence. For example, this 1 5 3 2 6 4 7 9 8, these are the numbers which are representing the city which are going to visit. So I'm just giving the example of traveling salesman problem. So how we are going to represent chromosome here? Like this. The city number 1 1 to 5 5 to 3. This solution is given by chromosome A, another is chromosome B. Okay. Third is value encoding. What is value encoding? Here just we will keep some values here. Value encoding means where we are use some values, such as real numbers are used, and where binary encoding would not suffice. We are not used to here binary encoding. For example, chromosome A will have some real value number 1.235, 5.323, 0.454, and chromosome V is left, back, left, right, forward. Okay. So this value encoding technique is good for some problems, but often necessary to develop some specific crossover and mutation techniques. So by using that crossover and mutation technique, we are used to develop some new that specific crossover and mutation technique should be used to develop these chromosomes. Okay. Okay. So this is the fitness function that I am discussing already discussed in brief, that will qualify for the optimality of the solution. Solution is chromosome, so that particular solution may be ranked against all the other solution. Okay. So this fitness function is assigned to each solution depending on how close it actually is to solving the problem. Okay. So ideal fitness function correlates closely to the goal and quickly computed, which can be quickly computable. We can calculate it quickly. So this is the ideal fitness function. So we have to find it for either it is optimal or not. We will check for it, that we have discussed in here. Okay. Then there is another term that is called recombination. Recombination means by recombining, we eliminate the bad solution and generate the new good solution. And also keep in mind, recombination is different from reproduction. Do not confuse with this. Okay. Reproduction is done to eliminate the bad solution. Okay. This. So we are going to identify the good solution. So there are several techniques for this selection process. For selecting, we are use a technique called as roulette wheel selection. Roulette wheel means, as we have several games were used on that. We just move the wheel, and wherever that wheel stops, that will be the assigned value for that fitness function. This is the roulette wheel selection. See, there is a string, fitness, and percentage of total. So we have assigned this fitness. This is an example. We have assigned this fitness 1, 2, 3. We will just move this wheel, and this percentage is very high. So this is the roulette wheel example. Okay. Now next, crossover. Crossover is the process in which two chromosomes combine their genetic material, and it will produce a new offspring. Okay. This is must to generate the new offspring. So there are several methods. Number one is single point crossover. This is important. Single point crossover is used as shown in example, string 2. After crossover, this will be combined with this second part of this string 2. We will get the new string 1. And another string we will get, this is the second part combined with this part. This is the string 2. After crossover, this is a single point crossover at one point. Randomly we will select the point and we will generate the new offspring. Okay. Second, this is the example using these bits. Okay, we have selected a point. This point we have selected. So this new bit will be generated here. We use here, and this use here. This is the offspring 1. Then another. This is the offspring 2. Okay, this is a single point crossover. 2 point crossover means we will randomly select the 2 points and to generate the new offspring. So we have selected this. Here we have used this chromosome 2, and again chromosome 1. This is the another offspring. So like this crossover method is very important. So like this, we can generate a new offspring. Okay. Then uniform crossover is there. We will uniformly select particular, randomly we will select, for example, 1011. Here we have selected 101 from the second chromosome, and 01 we will replace with, okay, and here we will get only one offspring using this uniform crossover, that we yield only one offspring, single point, 2 point, and number 3 is uniform crossover. So these are the techniques which we use for crossover. Okay, so crossover between two good solution may not always yields a better or a good solution. This we have to keep in mind. Okay, since parents are good, so probability of getting a good child is very high. Okay, so this is from the biological point of view. So if offspring is not good means the solution is very poor, then what we will do, we will just remove the next iteration during selection process that we have seen in the algorithm. Okay, so there are several terms. This elitism, I don't think so this is important. This is a method that will copy the best chromosome to the new offspring. Elitism, this is also a term, है ना? Mutation is a process by which string is deliberately changed so as to maintain diversity in the population set. This is our third important factor that is used in algorithm, है ना? So we saw in the, just as we have shown in the giraffe example, that mutation could be beneficial. The mutation probability determines how often the parts of a chromosome will be mutated. Okay, this is an example of mutation. So for example, we are using the binary encoding, randomly selected bits are inverted. So we have inverted this bit. In place of 1, I have used 0. In place of 1, I have used 0. Okay. So there are several advantages. This is one of the advantages, that is global search method. Okay, that is used, as we know that this, on the basis of this fitness function, we are just going to find the optimum solution. Okay, na? So this global search methods are used, that already I have discussed before. There are several methods that we used. For example, I have briefed it before also. Yeah, like here I have shown that what are the practical real world applications. Yeah, these are the. Okay, students. So I am finished. So I have just finished my concept. I think you all understand this. What is genetic algorithm? So you have to keep in mind these three concepts: selection, crossover, and mutation. What are the process that we use, and what are the nature to computer mapping. Okay, students. So thank you for today.